Hi friends, today I am discussing a machine learning. So what is the machine learning? So basic concept of the machine learning, and then we will try to describe each and every steps like a theoretically, and then I will go as a practical. So first, what is the machine learning? It's a machine learning is the subfield of artificial intelligence and science and engineering of making like a intelligent machine. So it's a if you see something like about we can show that like a relationship between the artificial intelligence, machine learning and deep learning. So artificial intelligence encompasses like other fields, which means that while all machines learning is artificial intelligence, not all AI is a machine learning. So you can say that like another branch of the artificial intelligence, like a symbolic artificial intelligence, was the predominant artificial intelligence research paradigm for the much of 20th century. So let's see. So if we see the diagram like so first we can see here like this is a artificial intelligence. Like this is a box like a AI, and it has been started approx we can see the like a 1950s, and similarly we will start here 1950, it's a 1960, and it's a 1970, and then we will see the 1980s, it's a 1980s, and it will start the another like a machine learning. It's an investment. Most of the it will start from like investment and interest in the machine learning like starts to grow, and end of this season like a 80, then it's a 90. These are the 19, it's a 1990, it's a 2000, and 2010 we see here it's a deep learning. It's a deep learning. Deep learning. So deep learning like a neural network and fast GPU pushes unprecedented like a AI boom and interest. So it's a good way try to understand like it's a these things. So another like a so all clear. So 1 minute. So these are the relationship between AI and machine learning. So the AI machine learning uses case like most of the time we are not using the today. The past decade has seen the astonishing series and advanced in the machine learning. So these are so we did used. So most of the time today where do we use a machine learning? So most of the industry like retails was one of the first industry to reap the benefits of the machine learning, and online shopping sites have real relied on the collaboratives and content-based filtering algorithms to personalize shopping experience. So online recommendations are highly targeted marketing companies generate millions of and something the billions of the revenue for the retailers. So like the so many companies, 35% of the Amazon's comes revenue, it comes to it's a recommendations engines. Another according to the study, like we will see here, and additional machine learning like applications like a retail includes the self-space planning, optimizations, targeting, marketing, customer segmentations, and demand forecasting. Similarly, just if you go the transportations, so almost every major auto manufacturers is working on AI-enabled autonomous vehicles powered by a deep neural network. So these vehicles are the fitted with a GPU enabled computers and that can process more than 100 trillion operations per second for the real time. So AI perceptions, navigations and path planning. So transportations and logistics companies such like UPS, FedEx uses the machine learning for route and fuel optimizations, fleet monitorings, preventing the maintenance, travel time estimations, and intelligence geo fencing. Another the financial service just a customer lifetime value and credit risk predictions, fraud detections are the some of the key machine learning uses the case for financial service. So hedge fund and investment bank use the machine learning to analyze the data from the Twitter Firehouse or to detect a tweet that are likely to move the market. And it's like so many examples like a financial service like include the predicting the best actions, churn predictions, sentiment analysis, multi-channel marketing attributes. And now if you go the healthcare and biochem technology, just healthcare is a crucial area of artificial intelligence and machine learning research applications. Hospitals and healthcare startups are using AI and machine learning to assist in accuracy, diagnosis, life threatening illness such as heart disease, cancer, tuberculosis. So AI drives drug discovery as well as imaging and diagnostics are the most representative sectors where the AI is gaining mm, transactions. Like AI also revolutionizes the way biotechnology and genomics research is conducted, learning the like new innovations in pathway analysis, microarray analysis, gene predictions, and functional annotations. And manufacturing field also just applying this field like forwarded the thinking the manufacturers like are using a deep learning for a quality inspections detect such as the cracks, uneven edges, and scratches on hardware products and etc. So these are the way. And another the government. So the machine learning has a wide range of applications in a government. For instance, the public utility companies have been using like a machine learning uh, to monitors utility like pipes and other so many fields. So machine learning has also been employed in the real time water quality monitoring, preventing disease from contaminations and potentially saving lives. Okay, so these are the way and we are using the machine learning. Another thing just machine learning and it's a depends on the data. So let's see the just if you we have a data like a anything any types of the data. So we can see here in the rows like these are the simples. So if you want to see here, look there, it's a data. I have a data, so you can see the 0 1 2 3. These are the sample observations. Look here, it's a all are there are the 48,842. And another just it has a one column like a age, work class, and FNL, wage, educational norm. So these are the columns. So all its columns are called like a feature. Features like attributes and dimensions has been given. So like a f and l vect, like its dimensions has been given so many, and these are the some features. Occupations is the, these are the features. So first we, and you can try like a targeted variables. So what is the targeted? So it's a according to what is your requirement, so you can take your targeted variable. So suppose I can take a targeted variable like a income. It's a data.info. So income should be a targeted variables according to the my requirement. So it's a way. So it's a, this is the data sets, and we can, so what should we do? The first step, we need to the observes this data. So observations is the first part. So we need to the observe here the data sets. So single row and data is known as the observations. And another, so there are multiple steps. So first is the observations. Your first step should be how to observe your data sets. Okay. So your first step should be observations. Observations. So single row and data is known as the observations or instance. Second point should be the feature. Features means the features is an attribute of an observations. The features are the independent variables used as input to the model, and features are like a, in this column so many features we have already discussed, like these are the educational norm, matrix, occupations. So these will be the features because it's a, all are dependent on the income. So income will change if any one features will be changed. And next is the class levels. So it's a depends on the variable, like a, another should be like a third point. It's a class levels. It's a class levels. So class levels is the dependent variable of the data set. So it's a, what is the class level? It's a income is dependent on the other factors, remaining the 13 columns. So the class level is a dependent variable in the data set. So it is the things that we are trying to predict. So it is the output. So outputs. And next the models. So we can, here the next point should be here fourth point. It's a models. So models like it's a mathematical constructor, and that has a predictive power. It estimates the relationship between independent and dependent variable in datasets. So this is the model. And fifth point, like a machine learning. It's a machine learning method. So there are different types of the machine learning methods. Deciding which to use depends largely on what you want to accomplish, as well as the kinds of raw data that you have. So it's a machine learning. It's divided in the different parts. One is the supervised machine learning, and another is, so first let's try to understand the supervised. Supervised learning is a machine learning task that makes the predictions using a training data sets. Like a supervised learning can categorized into the either classifications or regressions. So it's a supervised can be classified like a, can be classified like a classification or regressions. Classification and regressions. So the supervised learning categorized into either a classification or regressions. Regressions is the predicting continuous values such as the price, temperature or distance. So regressions, price, temperature, and it's a price, temperature and distance, and other is a yes or no. So it's a yes and it's a no, it's a spam or not spam. It's a not spam, milli, ginant. It's a these are the terms. Next, the classifications. It's a like a most of the common supervised machine learning tasks. So you most likely already encountered the applications that utilize the classifications without even realize. So popular cases include a medical diagnosis, targeted marketing, spam detections, credit risk. These are the classifications. So it's a there are three types of the classifications. So it's a classifications we try to understand. It's a like a, this one has been described like a three types. What is the binary classifications? Binary. Another is the multi-class classifications. Multi-class. And third is the multi-level. Multi-level classifications. So the binary classifications we have already discussed. Like binary classifications, if there is the only two categories, like a yes and no. It's a yes and no. This is the binary classifications, true and false, spam or not spam. Okay, so it's a binary classifications. Multi classifications means multi-class and multi-nomial classifications task have three and more categories. So like examples, to predict weather conditions you might have 5 categories: rainy, cloudy, sunny, snow and windy. So these are called multi-class. And other is the multi-level. So multi-level classifications, like multi-level classifications you can say here the like it's observations, you can say the contrast only the one category and can be assigned one to the observations of a multi-class classification using like a targeted marketing example. So multi-level classification is a use not only a predict and if customers is likely to make the other items such as buy a milk, and customer is coming at the shop, is at the shop, and they are they have a means they are buying only the milk, and but he has interest to buy the other product also. It's a multi-level classifications. So the classifications and regressions, it's algorithms. So the various classification and regressions algorithms has been developed over the years. So but we will try to the vary in the approach, like so there are some specific approach. So let's one thing first. So it's a some basic approach, like one of the approaches is the feature complexity, easy to use, training the performance, predictive accuracy, and these are the ways. So the let's describe the most of the popular ones of I will try to cover in this video, otherwise its video will be the very long, so don't worry. So it's a support vector machine. So support vector machine is a popular algorithms. So let's say is support support vector machine. So it's a support vector machine is a popular algorithms that works by finding the optimal hyperplane that maximize the margin between the two cases, driving the data points into the separate class by as a wide a gap as possible. So data points closest to the classification boundary known as the support vector. And another is the support logistic regressions is the so logistic regressions is the linear classifiers. It's a second is the logistic regressions. Regressions is a linear classifiers that predicts probability. It uses a logistic sigmoid function to transform its output into a probability value that can be mapped to two binary classes. Multi-class classifications is supported through multinomial logistics regressions. So linear classifiers such as the logistic regressions is suitable when your data is clear decision boundary. And after that we try like a naive Bayes. It's a Bayes theorem based. It's a NAIVE-BAYES. So naive Bayes is the simple multi-class linear classifications algorithm, and it's based on the Bayes theorem. So naive Bayes got the name because it naively assumed that the feature in a datasets are independent, ignoring any possible correlations between features. So this is not the case in the real world scenarios. Still naive Bayes tends to perform well, especially on small datasets and datasets with the high dimensionally like a linear classifiers. It performs the poorly on nonlinear classifier problems. So it's a another is the multi-layer perceptions. So multi-layer perceptions is the like a feed-forwarded artificial network that consists of several fully connected layer of the nodes. This is called the multi-layer perceptions. Next important is the decision tree. It's a decision tree like a decision. It's a tree predict the value of an output variables by a learning decision rules inferred from the input variable. So let's see the visually, and the decision tree looks like the tree inverted with the root node at the top. So one of the it's also the handling like some missing features and work with the both continuous and categorical features. So one hot encoding categorized features are not required and are the fact the discouraged when the using the decision tree and tree based ensembles. So one hot encoding creates the unbalanced trees and required a tree to grow the extremely the deep and achieve a good predictive performance. And after that it's a try to understand random forest. It's a random forest. So random forest is an ensembles algorithms, and that uses a collections of decision tree for classifications and regressions. It uses a method called like a bagging bootstrap aggregations. So it's a dependent on the bagging. Okay, and reduce the variance while maintaining a low bias. Bagging trains individual trees from the subsets of the train data. In addition to the bagging, random forest uses the another method called the feature bagging. It's called like a feature bagging. So in contrast to a bagging using the subsets of observations, feature bagging uses a subsets of features like a column. So feature bagging aim to reduce the correlations between the decision tree. So without feature bagging, the individual tree will be extremely similar, especially in situations where there are only the few dominant features. And for classifications, measure vote of the output of or the mode of individual tree becomes the final predictions of the model. So for regressions, the average of the output of individual tree become a final output. So like a spark trains several tree parallel senses the each of the trained independently of the random forest. So most of the time I am using in the spark like a parallelizations, tokenized is other things. After that, let's say random for boosted tree, random boosted tree. So let's try it here. The random, it's a the random boosted, it's a tree. So it's a gradient boosted tree, GB. It's not a random. Let's write here. It's a gradient, gradient. It's a gradient boosted tree. Is the another tree based ensembles algorithms. It's a ensembles, ensemble, ensembles algorithm similar to the random forest. So it's a, we can say the GBT use a technique known the boostings to create the strong learner from a weak learners. And one of the most of the things like the residual corrections process is also we will do. And after that we will do like a XG boost. XG boost is the extreme gradient boostings. It's a EXTREME, extreme gradient boostings. Gradient boosting is the one of the best gradient boosting implementations currently available, and it was released like a 2014. Okay, and XGBoost has become the dominant machine learning algorithm for the classifications and regressions. So XGBoost was designed using a general principle like a gradient boosting, combining the weak learners into the strong learners. And but while the gradient boosting tree are built sequentially, slowly learning from the data to improve its predictions and succeeding iterations, XGBoost build tree in parallel. So there is so many. It's a XGBoost produce the better predictions performance by the controlling a model and complexity and reduce the overfitting through the built-in regularizations. And it is used approximate algorithms to find split points when finding the best split point for the continuous feature. So the approximate splitting methods use the discrete bins and to bucket continuous features significantly, speeding up model training. So XGBoost includes the another tree growing methods, uses histogram based algorithms which provides an even the more efficient methods of bucketing continuous features into a discrete bins. But while the approximate methods create a new sets of the bins per iterations, and histograms based approach reduce bins over multiple iterations. So this approach allows for the additional optimizations and that are not achievable with the approximate methods such as like ability to the catch beans and parents in the siblings histograms subtractions. To optimize a strong operations like XGBoost stores sorted data in memory units of blocks. Storing of blocks can be efficiently and distributed and performance by a parallel CPU cores. XGBoost can effectively handle weighted data where its weighted quantile sketch algorithms can efficiently handle sparse data, is cache aware and supports out of the core computing by utilizing a disk space for a large data sets. So the data does not have a fit in a memory. So XGBoost not a part of the core Spark machine learning library, but it's available in the external package. So next is the light GBM. It's just we can say is the latest. So next is the light GBM. So for your light GBM has been everyone like a favorite go to the algorithms and for classifications and regressions both. So light GBM has emerged as the new challenge to the throne. So it is a relatively new tree-based gradient boosting variant similar to the XGBoost. So light GBM was released in 2016 and it's a part of the Microsoft distributed machine learning toolkits. It was designed to be the fast and distributed and resulting in a faster training speed and low memory usage. So it's supported like a GPU and parallel learning and the ability to handle a large data set. So light GBM has been shown the several benchmark and experiment in a public data sets to even a faster and when a better accuracy than XGBoost. So and after that just regressions means regressions we are going to discuss here. It's a one by one. So let's see. And regressions is supervised machine learning, not it's a, so regressions is a supervised machine learning and it's a task for predicting a continuous numerical value. It's a very popular. So the popular cases like include the sales demand forecast, predicting the stocks, homes, commodity price, weather forecastings, to the mention like a few. So the decision tree, random forest, gradient boosting, street, XGBoost, light GBM, they can also be use the regressions. Just I have already discussed. So it's a just we are talking about like a regressions. So what is it's a just 1 minute. It's a I am talking about like a regressions. It's a regressions. So first I will try to understand what is the linear regressions. Just we have already learned in the basic junior schools. It's a linear regressions. It's a nothing. It's a linear equations just means if you have writing like a x plus y, it's a two variable equations like a 5, it's a linear equations of the two variable. But if you write the 4x plus 3 will equal to 0, it's the one variable linear equation. So the linear regressions is used for examining the linear relationship between the one and more independent variables. So and dependent variables. So let's just if I write here y will equal to mx plus c, yeah, beta x plus c. So the x is a 1, so x is a dependent on the, if x is changing, y is also changing, so y is dependent on the x. So it's a linear, so single continuous dependent variable in the known the simple linear regressions. So multiple regressions is a linear regressions, you can say the extension of the simple linear regressions and predicting to the value dependent on the variable. Suppose let's see, just I am writing here, it's a this one y is a dependent on like this, it's a beta 1 x1 and it's a plus beta 2 and x2, this type of the variables you can say until n. So it's a multiple linear regressions. Next, the survival regressions. It's a very important. It's a another, we can say, the SURVI VAL regressions, REGRESSION regression. Survival regressions is known the analysis of the time to death or failure time analysis. So it's used to the predicting the time when the specified the event is going to happen. So the main feature of the differentiates the survival regressions from the linear regressions is the ability to the handle censorings and type of the missing data problems, and where the time and event is not known. So it's a, we discussed like a supervised. Let's see the discuss about like a unsupervised learning. So unsupervised learning is nothing but we try to understand so many unsupervised learning models. So let's see here. So unsupervised in the sense, just you can say the unsupervised learning is a machine learning task that find hidden pattern and structure in the data without the aid of level response. So it's a unsupervised learning, right? So the structure in the datasets without the aid of a level response. So unsupervised learning is the ideal and when you only have access to input data and training data is the unavailable or hard to obtain. So the common method include the clustering, topics, modelings, anomaly detections, recommendations, and principal component analysis. These are the part of the unsupervised learning. So it's a, these are the methods to the unsupervised, like a clustering, CLUSTERING, and anomaly detections and recommendations. It's the recommendations. PCA means principal component analysis. These are the, so let's start the clustering. So what is the clustering? So first, clustering is an unsupervised machine learning task for a grouping unlabeled observations that have some similarities. Popular clustering uses case include a customer segmentations, fraud analysis, and so clustering is also often used like a generate the training data for classifiers in a case where training data is scarce and unavailable. And after that, like a K means, so it's a K means is the one of the most popular unsupervised learning algorithm for clustering. So K mean work by randomly assigning centroids that are used as a starting point for each clusters. So the algorithms iteratively assigns the each data points to the nearest centroids based on the Euclidean distance. So then we can calculate the centroid of the each clusters by calculating the mean of the all points that are the part of that cluster. So algorithms stop iterating when predefined numbers of iterations is reached or every data points is assigned to its nearest centroid and there are the no more reassignments that can be performed. So after that we try to understand so some modeling. So the like us there are some models automatically derive the themes group of documents. So one of the models like the latent Dirichlet allocations, and it was the developed like in the 2003, and it's a one of the it is also called like a LDA. It's applied to the machine learning. It's the base of the graphical methods, and it is the first algorithms include the Spark machine learning library built in the GraphX. So LDA is a widely used the topics in modeling. So you keep in your mind. So let's see. It's a erasure and then latent district allocations. So this is the one of the models we apply. So LATENDIRICHLT district allocations. Okay, and next the anomaly detections. So anomaly detections, DETECTION. So anomaly detections like a outlier detection. This is called like a outlier detections. So it's a outlier detections identified. So anomaly detections like outlier detections identified that deviate the significantly and stand out from a majority of the datasets. It's a frequently used in discovering fraudulent financial transactions, identifying cybersecurity threats, and others. So it's a one of the this one is the isolation forest is a tree based ensembles. So isolation forest is a tree based ensembles algorithms for anomaly detections that was developed by Tony Liu and others. So it's a most anomaly detections techniques isolations forest try to the explicitly detect actual outliers instead of identifying normal data points. Isolations forest operates based on the fact that there are usually a small numbers of outliers in data sets and are therefore prone to the process of isolation. So isolating outliers from a normal data points is efficient since it requires the fewer continuous. So in contrast, isolation normal data points generally involve the more conditions. So similar to other tree-based ensembles, isolations forest it's a built the collections of decision trees known the isolation tree, and with the tree having the subsets of the entire data sets. And after that, so one class supports vectors, one class supports vector. This is called a SVM. So it's a one class supports vector. So support vector machines, support vector machines is the classified data. It's a classified data by dividing the data points into the separate class by as wide a gap possible using the most optimal hyperplane. So in the one class SVM is the model is trained on the data that has only one normal class data points that are unlike the normal example. Next, the dimensionally reductions. Reductions is the essential when there are the high number of features in your data sets. So when do you use a dimensionally? So dimensionality reductions. So dimensionally reductions is essential when there is a high number of features in your data sets. So I think we have already discussed the feature. So the machine learning use cases in the field of genomics and industrial analysis, for instance, usually involve the thousands or even the millions of features. High dimensionally mixed models more the complex, increasing the changes of overfitting. Adding a more feature at a certain point will actually decrease the performance of the model. So moreover, training on the high dimensional data requires the significant computing resources. So there are collectively known as a course of dimensionality reductions technique aim to overcome the curse of dimensionality. Principal component analysis, this is PCA. So it's a principal component component analysis. So it's a principal component analysis is an the unsupervised machine learning techniques and used to the reduce the dimensionality of a feature space. So it detects the correlations between the features and generates a reduced number of linearly uncorrelated features while the retain most of the variance in the original data set. So there is a more compact linear uncorrelated features is called the principal components. So the principal components are stored and descending order and explain the variance. Other dimensionally techniques like include singular value decomposition SVD and linear discriminant components LDA. And then recommendations, it's provide the personalized recommendations, one of the most popular applications the machine learning. And just a Netflix, Hulu, Spotify provides the movie just a recommendations basis. Next, another is the semi-supervised is getting the access the label the data and the costly the time consistent. So it's a reinforcement learning, try to the learn through the trial and error and determines the which actions provides a greatest rewards. So, and after that just it's a deep learning is the subfields the machine learning and artificial intelligence that uses the deep and multi-layers artificial neural network. It's also responsible for the many of the recent breakthrough in the artificial intelligence. And after that just neural networks are the class of algorithms that operate like a interconnected neurons of the human brain. So neural networks contains multiple layers that consist of the interconnected nodes, and they are usually the input layer and one and the more hidden layers and the output layers. So it's work the data as this way. Next, the convolutional neural networks is the types of the neural network that is the particularly the good analysis images, and that neurons in the layers of the convolutional neural networks are arranged in 3 dimensions: height, width, and depth. So CNN use the convolutional layers to learn the local pattern in its the input feature space, such as the textures, edges. So let's the feature engineering is the process of the transforming the data creates the features. They can be used the training the machine learning methods. So let's most of the time we will see the data scientist tasks like the cleaning and organizing a data like a 60% and consuming a time, and collecting a data set 19%, mining a data for a pattern like a 9%, refining an algorithm 4%, and building a train sets like a 3%. Feature selections is an important process for the step to identify the important features and eliminating irrelevant and redundant ones. So it's a improve the predictions performance and modeling training efficiency and reduce dimensionality. And filter methods, like so many methods in the filter methods ranking, such as the statistical techniques, so chi-square test and correlations coefficients and informations gains. So like one of the method, like a wrapper methods use the subsets of the feature of the trained models, so you can then add the delete and features based on the performance of the model. So ensemble methods like combines the technique uses like filter and wrapper methods. So popular example like lasso and rigid regressions, and regularized trees and random multi-dimensional logics. So feature importance like a tree based resemblance, such as like a random forest XGBoost and light GPM. It's provide the feature selections method based on the features importance scores that is calculated for each tree. And extractions is the essential for there is the high number of the features in your data sets. So machine learning use the field genome genomics and industrial analysis, for the instance usually involve the thousands or even the millions of the features. So feature constructions is the most important part. So and then the model evaluations. So model evaluations, let's see the classifications is the data points has known the label and the model produce the predicted class. So if we are comparing the known the label and predicted class, each data points the results of the classified into the one and of the four category, like a true positive where the predictions class is a positive and label is positive, true negative where the predicted class is negative and label is negative, false positive where the predicted class is positive but label is negative, and false negative where the predicted class is negative and label is positive. So these four values form the basis on the most evaluations matrices for a classification task, and they are often presented like a some tables, you can like a matrix format table, and this table is called a confusion matrices. Then we try to discuss like accuracy, and accuracy is the evaluations matrix for classification model. It is defined as the number of correct predictions divided by the total number of predictions. Like accuracy should be equal to like a true positive plus true negative divided by the true positive plus true negative plus false positive and plus false negative. So the accuracy is not ideal matrix in a situations where you have imbalanced data sets. Says so sometimes we will see the like suppose like a hypothetical classification tasks like the 90 negative and 10 positive samples. So classifying all the negative gives the 90% accuracy score. Persistence and recall is the better matrices for evaluating the trend and class balanced data. So the persistence is the define the number of the true positive divided by the number of the true positive numbers or false positive. So the true positive divided by the true positive plus false positive, this is called a persistence. So your model perceives the 90%. So precision is the good matrices use the situations where the cost of false positive are high. Recall is the good matrices used for situations where the cost false is the negative is high. So recall is defined as the number of true positive divided by the true positive plus false negative. And F1 measures F1 score is the harmonic mean of the weighted average of precisions and recalls. So it's a common, so F1 measures will equal to twice and precision x scores and plus precision plus recalls. So it's a F1, so the best F1 score is a 1, so while it's a worst score is the 0. So good F1 measures means that you have a false negative and low false positive. So F1 measures is the better way. So now the next the area, the receivers of operating characteristics means AUROC. The area under the receivers operating characteristics is the common performance metrics for evaluating binary classifiers. So the receiver operating characteristics means ROC is a graph that plots the true positive rate against the false positive rate. And the area under the curve, like AOC, the area below the ROC curve. So AOC can be interpreted as the probability of the model rank random positive example higher than random negative example. So larger area under the curve, the better model performing, and the model AUROC is like a 0.5 unless since predictive accuracy just the good at a random guessing. And then overfitting and underfitting. So it's a model, either the overfitting and underfitting. So overfitting refers to the model that fit the training data too well, and overfitting model performs the well against the training data but performs the poorly against the new and unseen data. It's the opposite like a overfitting. The underfitting, with the underfitting models is the two samples and they have learned the relevant pattern in the training data sets, either because the model is the over regularized or needs to the train longer. So let's the model selections, it's a depends on you, and then we will do this process. So let's see here, it's a I have taken a data like this one in the adult CVC. So it's a very number of the columns and I have described one by one. It's a method data, it's a how many null sets and how do we remove these null sets. So let's say we are trying to the heat map, and then it's a null and data, it's a column. So it's a occupations columns I have taken and described the how to replace like some question marks in this data. And so and then we will draw plot like again heat map, and we see here and how do we drop the any other rows and columns, how to create a duplicates. So I have done. So next time I will try to discuss these all theoretical parts in the one by one like in the practical way. So data we have done because there is no need the educational norms, capital gains and capital loss in the data. So we are cleaning this data because it's a, and then after cleaning this data we are going to plot here the data. So if you want to the plot like this way, it's the histograms, and then we are doing this is the way to the process itself. So I hope you try to understand something, and then we will plot like the box plots. It could describe like the medians, quartile, q1, q2, okay, other factors. So it's a good. So thank you very much, and we will discuss next time.